let me hand you over to the first team, who are called RaPido!
Hi everybody and welcome. We are Team RaPido. So our team members are, starting from the left, is Tarek, David, Tom and Al. So today we're going to show you our product and how it works. Before we get into that we're going to do something which is... So before we do that, I'm going to tell you a little bit about what it is. The idea behind this was for the product to be available to the public and to pass videos to the council or social media. As we are aware, speed cameras are and do exist. However, these are owned by the local council, which we do not have access to. So basically, our product is a speed camera. I missed that bit out, but I'll pass you over to Alistair now.
Thank you. Thanks, Hassan. Okay, Tarek, run the video. Okay, we start on the login screen, which looks a bit blurry for some reason. This app was built in React. If you don't have an account, you can create one. But we already have an account, so we'll just log in now. And we've used Google's Firebase authentication for this. We're now on the live stream page. For the purposes of the demonstration, we've used a pre-recorded video. And here we view the live stream, which is very blurry, and record a clip. And this clip will then be saved and uploaded to our AWS S3 bucket for processing. And once processed, it's saved to our video library bucket, which we can access here. It just takes a few seconds to get the videos from the cloud storage. And we'll start with this video. This is Tarek spying from his bedroom window. Love the blinds, Tarek. This car isn't speeding, so we'll move on to the next clip. And in the next clip, we're tracking 3 vehicles. And there's our first potential speeder. The camera has detected the other cars, but maybe not had quite enough time to evaluate the speeds. And here we have a video taken on a motorway, just to show it works on motorways. We've actually taken this with a phone, as Tarek didn't have the Raspberry Pi with him at the time. And I think one of the cars there, although you can't see it because it's really blurry for some reason, one of the cars was looking like it might be over the limit. So we'll see if we've got any more information. We just click on more info, and we can't see that it shows the 3 cars and their speeds, and there's also a button which shows an image of the speeding vehicle. That's automatically generated when it's processed, and it finds a car over our preset limit. And we can also see the image from the 33 mile an hour car. And then we can download this video. And we can add this video to our other videos of potentially speeding cars. Could pass these on to the council when asking for speed bumps or other traffic calming measures in the area. Or we could just shame people on social media. Any videos we've finished with can be deleted from the cloud storage. And then we have a settings page where the user can change settings like camera settings, speed settings, change email address, change password, and then we log out. And I'll pass you back to Hassan to talk about our tech choices.
Cheers. So I'm just going to talk to you about the front end a little bit when it's there. Skip the thing. Yes, I'm just going to talk to you about the front end and React and why we used it. So we use React to produce a front end web application. The reason we used this was due to the whole team being familiar with this and we've used this throughout the course. We knew even before starting the project that if the issues did occur, we could debug the issues through pair programming or collectively as a team. HTML and CSS, as we must all be aware, that these are a necessity for creating the front-end web application and the style and how it looks. Mocha and Chai, just used for testing functions. An example of this was just extracting the date information from the file name. And a little bit about backend, which is Firebase. This is something new that we learned. It's quite interesting as well. And really, we only use this for user authentication, so when the user logs in and logs out. I'll pass you on to Tom, who'll talk about the backend.
So we had three main things that we needed to do. We needed to track a car, or detect the car, track the car, and then get the speed of that car. We definitely wanted to use a different language when we was doing this, so we did some research. We found the best languages to do object detection was C, C++, and Java, and Python as well. So we did go for Python because it has a lot of similarities with JavaScript, which we all knew, has a lot of good documentation and good online tutorials. And we also thought it would have just been a better suited challenge for us instead of doing some of those high-level languages like Java and C++. When we came to actually detecting the cars and did some research, we found an open source Python library called OpenCV, which actually detects the cars and does a lot of heavy lifting for us, so that made it a lot better. So when we used OpenCV for detecting the cars, we had to do a lot of math to actually calculate the speed. Once they gave us some of the information on them. Learning Python wasn't as bad as we initially thought as a group. I think just because we all learned best by actually just diving in and just coding really, looking at other people's examples and how they did it and just seeing how the actual syntax works in Python really. But I do think learning OpenCV was a lot harder than Python just because we had to learn a lot of the functions, which ones do what, which ones we actually needed and how they all work together. Yeah. And when we decided to stream the Pi, we decided to stream from the Pi to a separate server because the Pi wasn't actually powerful enough to do the processing for the video and actually do the object detection in real time. So we initially looked at Firebase for video streaming and the processing, but it was just too difficult really. So we turned our attention to AWS because it has a whole suite of services that we can use and just pull from, and that meet all our requirements just all-in-one as well. So when a video is recorded on the front end, it is then sent to an S3 bucket, which is one of those services, which then also triggers the Lambda function, and that actually holds our Python code and then processes the video as well. As it's processing on completion, it creates and then saves a video, which includes all the findings and shows the speed of each car in the video as well. And if there is any speed in cars, it saves a photo like you just seen. Lastly, all the processed videos are stored on our AWS backend, which are then sent to the front end on request, really. I'll pass you over to David, who will talk about our problems with the project.
Thank you there. Okay, so just checking the mic's still on. We encountered a ton of problems on this project, but with limited time, I'll just give you a couple of the top picks here. So to keep things simple, we initially, as we said, wanted the Pi to handle image processing, video storage, and video serving. But although the Pi has come a long way in terms of its processing power, it still wasn't able to handle all of those things, particularly image processing. This led to the decision to outsource most of those tasks to something with a bit more grunt, effectively turning our use of the Pi into just a webcam, where the remaining jobs were handled in a serverless environment. We also wanted a continuous video stream to be input, where we would then output a continuous video stream showing you the speeding vehicles in real time, similar to a traditional speed camera. But to do this, there was still an issue with lag. So to get around this, we settled on having the user manually start and stop recording, where calculations are only performed once the recording is stopped. I'm now going to hand you over to Tariq, who will talk to you about lessons learned.
Thank you. Yes, it's still Okay, so I'm going to be talking about the lessons we've learned over the last 2 weeks and what we will do differently next time. So we actually did plan pretty well at the start. We got all our techs that we were going to use for the front end and back end, and even the hardware. But we realized that we underestimated how much we actually have to go into depth with this research. So for example, it's been mentioned before, we did put OpenCV onto the Raspberry Pi at first because we were thinking the video would be processed on the Pi, but that wasn't the case. And that actually took 2 days to install onto the Pi. And so that wasn't the case. We were actually going to process the video using the Lambda function. So that was 2 days worth of time taken where it could be spent elsewhere. So, and relating to the errors that kept on popping up like that, optimism. That's another lesson we've learned. Always keep optimistic. So when something goes wrong, the morale of the group tends to drop a bit, and that means there's less productivity happening. We quickly usually turn that around by being optimistic and knowing that every problem has a solution. So just remain optimistic. And then last, we did, as you know, we did use a new language, which was Python. At first, we were going to use hours worth of tutorials to learn this, but we quickly realized that this would take a lot of time to do. So what we did was we actually just jumped headfirst into the product and into the processing of the video, and we learned on the job, basically. So, for example, we thought of how we would do that using JavaScript, and then, so for example, if we needed to use a for loop to loop over something, we would just Google how to loop over this in Python, and then that's how we learned Python, and it was actually a really good system. So that's what I've learned, and we've learned to do if we were to learn a new language. Yeah. Yeah. And I've also actually learned that after 3 months, it's really hot in here, so don't wear a jumper. Yeah, I'm sweating. Okay, that's it. Thank you. Woo!